Hello and welcome to the overview of PLAXIS Limit Equilibrium software. Today we're going to discuss the 2D geometry basic concepts within PLAXIS 2D LE. My name is Marina Trevisoli and I'll be walking you through the overview of the training. The agenda for today is based on one key question: how do we create geometry using PLAXIS 2D LE? So to answer this question we need to cover some topics: the CAD Drawing Space, geometry objects definition, 2D geometry concepts, importing possibilities, and tools for handling geometry. The first aspect related to entry of geometry is in terms of the CAD drawing space available in the software. This is central to the entry of a new numerical model. A general description of the use, besides the entry of geometry related to the drawing space, can be found under the user's manual available with the software. This session will focus on the aspects of the drawing space which can be utilized for the entry of geometry. In this image, we can see the interface of PLAXIS 2D LE, including the CAD Drawing Space. This CAD user interface of PLAXIS LE software can be conceptualized as a simplified version of a CAD software. Besides that, we can see here on the top that if we follow the workflow on a left to right fashion, we'll be able to create the whole geometry and proceed with slope stability analysis. Our goal today is focusing on number 2, related to the dialog referring to the geometry entry. In order for the user to successfully make use of the software, they must become familiar with the following elements in the interface. The geometry menu provides all dialogues controlling the properties of model geometry. You can access the tools related to manipulating geometry, importing options, region properties, all accessing the geometry menu. Here there is also the region combo box that displays the currently selected region in the model. So you can have plenty of regions. We'll understand later what regions refer to, and all operations based on the regions that are selected will happen on the current one in place. You can also identify grid selector and snap selector tools available for our users. For the grid selector, these options control whether or not the current grid is displaced and also the spacing of the grid. The snapping is an option that flips on and off whether or not the user will snap to the current defined grid, helping users to better draw their geometry. Numerical models are built based on the concepts of basic geometry building blocks. In PLAXIS LE, we need to understand two main principles related to basic geometry. So the first principle is that a closed polyline is actually called a region in the software. User can create several regions for a model or only have one region that represents the entire geometry. The principle too is that material properties are linked to the regions. Therefore, the regions, as we can see here, can have material properties related to the same or different type of soil rock. So when the user creates model geometry, they must consider how many regions will comprise the model and their placement. All the geometries are entered within the context of the current world coordinate system and the model system. These contours can be adjusted in the software, and the geometry can be entered in a number of different ways. Users can pick the one that are in accordance with their available data. So the first one is drawing the geometry directly using the CAD tools provided in the software. We can also cut and paste the geometry data directly from other software, such as Microsoft Excel. We can manually type the coordinates of the regions. We can import geometry from external sources, such as DXF, shapefiles, and so on. Another option is transferring the 2D slice models from PLAXIS Designer in case that the user has developed a 3D conceptual model. So what is a region? A region in PLAXIS LE is the basic building block for a model. A region represents both a physical portion of material being modeled and a visualization area in the PLAXIS LE CAD workspace. A region is similar to a layer in CAD, in that it can contain any number of geometric shapes. Other modeling objects, including features, text, line arts, and so on, may be associated with a given region, besides, of course, the material properties. By definition, region shapes contain edges. There are also unique considerations of edges given in the slope stability software package. For example, the dynamic programming algorithm needs to have a definition of the series of edges which make up the upper ground surface. Many of these edges definitions are handled automatically by the software through algorithms which run the background. These algorithms are designed to make the entry of the geometry easy. Important to note that all regions need to form a continuum. By that we are referring to closed polylines. This means that there generally must be some continuity between region shapes in that they must be touching at some points. This does not negate the fact that void regions may be defined, or in certain specialized cases there may be air gaps between regions which are physically realistic. To consider the continuity of a region, this can be done through the use of edges and points, as shown in the image below. The regions are linked through sharing the same points or regions, as you can see indicated in point 1 and 2. PLAXIS LE supports overlapping of regions in all software products. This greatly simplifies the entry of certain models as the requirements for geometry input are relaxed. For example, in this model here referring to a dam, it would be difficult to draw the core region indicated in brown if overlapping regions are not possible. Without overlap, the dam region must be drawn to follow around the core region of the model. With overlap regions, the dam region can be drawn to completely encompass the core region. Then, the core region can be given an order in the regions dialog, which is higher than the dam region, which indicates to the solver that the properties of the core region override the dam region. As we can see here, the brown color indicating that the core shape has a higher order compared to the dam. It's also important to note the following points when working with regions in the software. So regions may contain cutouts or void sections by defining a secondary shape and then marking that shape as dominant. Boundary conditions can be defined at any shape edge within a region. Some features must be drawn as to be internal to the region, in the case of finite element models, like forged node points, internal boundary conditions, and so on. Some users prefer to transfer the data from external sources, and this is completely fine. The geometry can be defined by importing from external sources. The important feature is available under the geometry menu. As you can see here, we have plenty of options for importing profiles, regions in PLAXIS 2D LE by the use of DXF files, shapefile, an existing model from another PLAXIS LE, for example, results file that can be also reused as geometry, Microsoft Excel containing the model coordinates, and GeoStudio models as well, presenting the import of a geometry in PLAXIS LE. So we can access the import option under the geometry dialog by selecting importing. In this case, we're going to pick a DXF file. When we click, we need to identify the file location. In that sense, we can click on Browse and look for the directory that includes the DXF file, as we can see here. The user has some options on the use of the polyline options to join start and end points for every polyline to make sure that it's a closed polygon. And when we proceed to the import setup, we can see all the objects included in the DXF file. Each of these objects refer to closed polylines in this case. The user can select them all, click on View Selection, and see the geometry preview before importing and make sure that all looks correct in this session. After doing this, we can click on Import Selected Objects, and the software will let us know how many regions were imported. We'll click OK, close the dialog, and now we can see all the regions that were included in this model. If we return to Geometry Regions dialog, we can then see for each of the regions the properties related to coordinates and so on. Users can now apply the material properties. Besides drawing regions, importing, there's also the requirements of having some tools to adjust these regions in case it's needed. For handling the geometric objects available in PLAXIS LE, users can access the Tools dialog available under the Geometry menu and use the ones that are mostly aligned to their needs. For example, in this case, we can use the Offset. So under Geometry Tools, we can select Offset. This function is its simple utility function shift the entire model by a fixed amount in XY space. As we can see here, we proceed with an offset of 10 meters of the model, of the entire model. We can also rotate the model, in this case selecting the option Rotate, and rotate all model points by some fixed amount. In this case, we can select the coordinate of the grid point you wish to rotate around and the angle of rotation in degrees. The model will then be rotated. The Extrude function is a drawing add used to quickly create an adjacent region at a fixed vertical height above the current selected region. So in this case, the user can select the point selections and in the drawing space select 2 points of the region. Then, under the Extrude option, they can define the height, y coordinate, of the upper edge of the new region you wish to create. In this case, we can see that a new region was created by the use of these points of reference. The adjacent region will contain all necessary points to precisely touch your existing region. Let's say you'd like to slice an existing region. You can do this by selecting under the Tools, the Slice region with Polygon or Polyline. So if selecting with Polygon, we can, under the certain region, in this case region 1, draw an internal polygon, and then this polygon will intersect and slice the existing region 1, creating then 2 additional regions. We can also slice regions using polylines. So under the polylines, instead of drawing a polygon, we can then just draw a line in this case, and the line will subdivide a region as well, slicing and creating additional regions in the model. Region intersection is a powerful tool available in PLAXIS 2D LE to generate new region data from the intersections of existing regions. We can use this tool in 2 different ways: an automatic way, and let the software identify all the possible intersections and fix it, or also the manual approach. Let's first see the automatic. So we can notice in this model that there are 3 regions set, and region 3, which is this one, and region 2, have this portion of overlap. We can fix this by clicking on the Geometry menu, accessing the Tools, and selecting the Automatic Region Intersection. When we select this option, we can click on Generate All Geometries and the software will let us know what are the additional regions included in the model due to intersection and what are the original regions that were modified. So we can notice here that an additional region was added, which refers to the name region 2 intersection 1, and we had to modify two additional surfaces, which are referring to region 2 and region 3. If we click OK, we can see then that now we have this portion here, which refers to the exact name obtained when using the tool, and these two other ones that were fixed. We can keep the model as we see, or we could even take this intersection here and select the region below or above, right-click, and merge two selected regions. Then click OK. We can see that now we have another region called union of region 2 and region 2 intersection. If we want to undo the action and reselect the two regions again, right-click, we can also delete the original regions and just keep the new one. For the region intersection 2, when proceeding with the manual operation, here's what we can do. Using the same example of having region 2 and region 2 intersecting, we can proceed with Region menu, Tools, and select the option Region Union Intersection. When handling the manual operation, we need to adjust the analysis by selecting a subject region and a clip region. So the subject region is the one that is subject to the operation, and the clip one is the one that is acting on the operation. So in this case, we may have region 2 as subject region and region 2, which is the clip one. If you'd like to modify the subject one, we could select the option of modifying the subject region. Here we can see that we have 4 different options in terms of operating these two regions. So we can find the region intersection, join these two regions together, remove the clip region from the subject region, or find region non-intersecting. If we click on Find Region Intersecting and on Generate, we'll notice that an additional region was added in the model called Region 2 Intersection 1, which is similar to the automatic approach. We can also 2 and 3 and proceed with a different approach. So let's say that we would like to remove the clip regions from the subject region. Click on Generate, and you'll notice that a region 5 was created, which is a region that is not intersecting anymore with the region 3. So you can notice that we have this region 2 intersection, region 5, and so on. So it's up to the user to make these manual adjustments and achieve the result that they were looking for. This next example refers to the use of the tool Fix Region Geometry. This is a key action that can be applied in the models when you're having some kind of geometry issue blocking you to proceed with the analysis. So let's simulate a case that we'll need to use the Fix Region Geometry. We have 3 regions in the model, and between region 1 and 2, it seems that all connections are right. But if we zoom in, we can see that actually this point here is not properly connected to the region below, causing a problem when proceeding with the analysis. Another thing is happening here between region 3 and 2. So region 3 has a point here on this portion that is causing this overlapping on the region below. These two actions can be corrected using the Fix Region Geometry. So in this case, we come here under Geometry Tools, select Fix Region Geometry, and basically this tool will recreate the regions as new ones, having the original ones as reference, but taking all existing points and light segments and applying a certain merge distance that the user can define. This merge distance is applied to the points, and then it will split any segment with points that are within the specified distance to the segment. So with a sufficiently large tolerance, this action can fix most region geometry issues that cause problems with the model, such as gaps between regions, overhanging regions on the ground edges, extremely thin layers, and more. So if we proceed, by default we have the tolerance as 0.01, okay, and we can see that the tool actually corrected the connection of these two regions, and consequently here use the nearest point as reference in this case for properly connecting the region 3 and 2. Users have the ability to reduce the number of regions points in a complex model without changing the overall geometry. So in this case, we can see that there are plenty of points in this cross-section. We can click on line simplification, choose the algorithm that we would like to use, set its options, and then generate the line simplification. As we can see in this example, we decrease the quantity of points. This option can be important in some cases that the region point must cause an excessive analysis time if the region geometry contains a large number of extraneous points. The measure option is an extra option in case we want to make a certain measurement. So by selecting the line of measurement, we can then see all information in terms of length, slope, angle, and so on. Thank you for your attention.